So, 9.1, please. A sequence is a set of numbers in a specific order. The first term is denoted a sub 1. The second term denoted a sub 2, and so on until you get to the nth term, a sub n. So this is actually very, very simple. If I want to find the first four terms of the sequence, a sub n equals 3n minus 2. So a sub 1 is going to be 3 times 1 minus 2. So that's a 1. If I want to find the second term, that means n is 2. 6 minus 2 is 4. The third term would be 3 times 3 minus 2. That's 7. A sub 4 would be 3 times 4 minus 2. That's 10. Because some of these are going to get complicated, what I want you to do when you're done is then take a moment and list the first four terms, right? 1, 4, 7, 10. All right, I'm going to give you a head start, and I want you to try letter B. Yes?
Is there always some sort of pattern?
There is always some sort of pattern. It does not mean it's addition. It will be a variety of things. So
if you figure it out, can you just write the next answers? Or?
Correct, yes. Yes, absolutely. You want to do that.
You do like 20 terms.
Stay awake. In letter B, do you notice that when it's an odd power, you're subtracting, even powers, you're adding? So this is just going to alternate 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, okay? All right, in example 2, if I want to find the first 5 terms, so notice it did ask for 5. This will be 2 times 1 is 2, negative 1 to the first. So that's 5 minus 2 is 3. You do as much work as you need. Some of you don't need to write as much, and that's fine. And some of us do need to write a lot more, and that's okay. So now when I square the negative 1, that makes it positive 1. So you see that that's 9. So I have the list 3, 9, negative 1, 13, negative 5. Do you guys get that? So this part's the easy part. The tricky part is what we're going to do in reverse. I'm going to give you a sequence, and remember, a sequence is a set of numbers in a specific order. There's usually some sort of pattern to it, but it doesn't have to be addition and subtraction only. Because clearly that's not what's going on here. Did everybody have this? So, we're going to look at these 4. In the earlier period, they got very, very frustrated. Okay, they got very, very frustrated, and then they got mad because I was laughing. I didn't mean to laugh at them, but I was like, it is some guess and check to some of this. It says, write an expression for the apparent nth term of a sub n. So what I'm asking you is I'm asking you to come up with a sub n equals something that has an n in it. So there should be some sort of pattern, and the more experience you get with this, the easier it is. And for some of you, you are going to absolutely love doing these. You're going to think it's like a puzzle and you're trying to figure it out. For others of you, you're going to be very, very frustrated. So but we need to work to the point where we can all do this. So if I look at this, and here's something I like to do when I'm trying to come up with it, is this is the first term, the second term, the third term, the fourth term. And what you're actually being asked to do is you're trying to find an expression that when I plug in n for the nth term, it works in any of the positions. Does anybody want to try it? Could you come up with something? Anybody have it? Yeah, Tyler?
1 plus 2n.
Let's try it. I don't know. But so if I plug in that n is 1, that's 3. That didn't work. You're almost there.
Is it just n plus 2? I'm already angry.
You think it's n plus 2. Let's see.
The one.
Well, that didn't
Negative
work on
1
the
plus
first one.
2n. 2n minus 1.
All right, I heard 2n minus 1. Let's try that one. Okay. If I let n be 1, that's 2 minus 1 is 1. If I plug in 2, 2 times 2 is 4. 4 minus 1 is 3. Ding, ding, ding. We have a winner. 3, 6 minus 1 is 5. Okay, now, in this one, you should notice that there was a difference of 2. When you see a common difference, it is going to be that number times n, and you're going to plus or minus to figure that out, okay? That is true with that case. But if you look at letter B, I don't have a common difference. It's going up 3, then 5, then 7. So darn, that isn't going to help us. So I'm going to give you a few minutes, and I want you to try B, C, and D. And I want you to just try to think about some other number patterns you have. And is there something you can think of, and sometimes you have to add and subtract to them. Letter C, do you remember how in one of the previous examples we had a negative 1 to the n power? That can make it alternate signs. But starting with n is 1, I don't want it to be positive. If I have negative 1 to the n, that starts negative. So you got to mess with that a little bit. Does anybody have letter B? Emily, what do you think?
I have a sub n equals n squared plus 1.
Awesome. Okay. All right. So her brain is wired here. That if you think about this, n squareds are 1, 4, 9, 16, and so on. So you have to think of your perfect square numbers, and it's 1 more than that. So this is going to go in our tool belt. All right. I got to think about n squared. Sometimes it can be n cubed. That's another one. All right, anybody want to try letter C? Anybody have it? And sometimes there is more than one way to write it, but you've got to make sure you're checking all the terms, because it might work for the first one, but it doesn't work for any others. But on letter C, I've got at least 2 ways I can write this one, but they're very, very similar. Well, how do you get the 2, 4, 6, 8, 10? You should be able to tell me that, right? 2n. Okay, that's 2n. And then we need the signs to alternate. But if I do an n, it makes it negative 2 and positive 4. I don't want that. So what could I do to the exponent that could make it, instead of starting negative, would start positive? I could either make it n plus 1 or n minus 1. Do you see that? Okay, here's the other option. I could have said it was negative 2n times negative 1 to the n. Do you see that? Because then that really is negative 1 to the n plus 1. Okay, so that's equivalent. All right, now, in letter D, the bottom you should have gotten, isn't that 3 to the n power? because it's 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. In the numerator, you know, good first attempt would be 2 to the n, but the problem is 2 to the 1 is 2. I'm off 1 power. So what could I stick in my numerator to make it start 1 less than that? Hint, hint, hint. That would be 2 to the n minus 1. It can't be 2 times n, because then I would need this to be a 6 and not an 8, okay? Alright, so this will be a challenge for us in general, but now you know, okay, I can look for a common difference, I can look for perfect squares, I can look for a number to a power, I can alternate my signs if I need to. Alright, some sequences are defined recursively. To define the sequence recursively, you need to be given an initial term, and the rest of the terms are defined in terms of the previous terms. I gave you a paper that talked about bunny rabbits. Can you find that for me? And it says A is the number of pairs of baby rabbits born today at 12:01 a.m. on the first day of each month beginning on January 1. B is the number of pairs of rabbits 1 month old. C is the number of pairs of rabbits 2 months old or older. And D is the total number of pairs of rabbits. This is the rabbit problem that Fibonacci worked on. And then what he came up with is fondly referred to as the Fibonacci sequence. Something else I need to tell you is that rabbits can start reproducing when they are 2 months old. So we're going to start January 1,
Puberty hits fast.
and we have a pair of baby rabbits are born, okay? Then 1 month later, so you have a chart. 1 month later, those babies are 1 month old. Then what happens is, March 1st, those 1 month olds become 2 months old, and they reproduce. And they just have 1 pair. Whoops. So D is now 2. Alright, so the new babies become 1 month olds. My 2 month olds now, they're 3 months old, but they're in the 2 or older. But they reproduce again.
How quick can they have babies?
Every month.
Oh.
Is this
Every
real
month.
for rabbits?
What?
Is this real facts for rabbits?
Uh-huh.
Oh.
Yeah.
That's why they're winning.
Fun fact of the day.
This is why they're winning. Yeah, really? I put rabbit genes in humans.
Okay, so now, May 1st. Let's stop and think here a moment. These 1 month olds become 2 month olds. So now we have 2 pairs of reproducing pairs of bunnies. So now there's 2 sets of babies, but the babies from April 1st became 1 month olds. So now we have 5 pairs of bunnies. Alright, this is where it's going to get interesting. Now, this 1 month old from May becomes 2 month olds, or we'll just call them adults. Now we have 3 pairs, and they reproduce. But we had 2 pairs of bunnies that are now 1 month olds. So how many pairs of bunnies do we have? 8. Okay, so now how many adults do we have? 5, and they have 5 sets of babies. And how many 1 month olds do we have? 3. So that's 13.
This is getting out of hand.
Okay, so now how many adults do we have? 8, and they reproduce and have 8 sets. How many 1-month-olds do we have? 5. So how many is that? 21. Wow, okay. September. This is getting out of hand. All right, so how many adults do we have in September? 13. So they have 13 sets of babies. How many 1-month-olds do we have? 8. Yikes. Okay, so we're up to 34.
This is when you start making the little stuff.
How long do rabbits live?
That's a problem.
It's my understanding they don't live that long, so.
Yeah, I mean, and that's why, I mean, in my neighborhood, we have lots of bunnies.
Question
The
is,
front,
he wasn't having why.
where we have a big rock and there's 2 bushes, there's a family that lives in those bushes. But then you'll hear at night sometimes where a cat will get to the bunnies.
My dog brought me one the
Bunnies
other
hate
day.
cats. They kick their butts, so.
True story. my
Okay,
dog brought me one.
so do you get 21, 13, 21? All right, try November on your own. Try to figure that one out.
This is
And then go ahead to December. Did anybody get a total yet for December? 144, right? Okay, what I want you to do then is, in that space between D is total number of pairs of rabbits and January 1, let's make a list of these numbers. Whoa, pick the wrong color. Here's 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. But there's a pattern here in this sequence. Can anybody describe what the pattern is? Tyler?
I can kind of describe it. I can't put it to an equation or anything.
And that's okay, yeah, just describe it.
But okay, so like after like whatever's on the sides goes down to the next answer in the middle, and then whatever was 2 answers before it goes to the sides in the next sequence, like the next 3.
That's true in the chart.
But,
I mean, looking at this list of
Oh, I
numbers,
don't-
do you see a pattern here? Like, how do you get the next number? There's a pattern, not looking at the chart, okay, but just looking at the list of numbers. There is a pattern going on. Does anybody see it?
It like skips a number when you add.
Except for 1.
What do you mean it skips a number?
Never mind.
Emily?
It's like the 2 pairs of, so 1 plus 1 equals to 2, and then 1 plus 2 equals 3.
Okay, do you see that? 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. If you add the previous 2, it'll give you the next one. So without continuing our chart, we could add 89 plus 144, and that would tell us how many rabbits we would have January 1, a whole year later. That's a lot of rabbits. That is a lot of rabbits. Okay, so let's go back to our notes.
How can we write that as an equation?
That's what we're going to see. All right. The Fibonacci sequence is defined recursively. And recursively is different from that first group we did, where we said like a sub n was 3n minus 1. That can be found, that's called an explicit formula, where you can go find the 99th term using that. With recursive, you need to know the previous one or the previous 2. So with the Fibonacci sequence, and sometimes they start with 1 as the a sub 1 is the first term, and sometimes they start with a sub 0. I'm not quite sure why they would want to do that. It wouldn't matter if you said a sub 1, a sub 2. It's the same thing, okay? But then here, this is notation that's going to be very, very abstract. So it says a sub 0 is 1, a sub 1 is 1. A sub k means I'm going to the very next one. So that would have to be that a sub 2 is going to equal, okay? So if I have k is 2, then you have 2 minus 2 would be a sub 0 plus 2 minus 1. So this is saying, if I look above, it's 1 plus 1 is 2. Then if I want to do a sub 3, that's a sub 1 plus a sub 2. Well, a sub 1 is the second one right here, plus the 2 is 3. And then something Ben asked earlier that connects here as well is if you see the pattern, you don't need to keep computing it. You just go then once you see the pattern. And so I want you to think about it. If this is k minus 2 is 2 terms in front of it. K minus 1 is the term in front of it. So like if I'm, working this out and I'm at the 10th one, this is the 8th term and the 9th term. That's what that means. Okay, it's a little bit abstract. So let's look at example 5. It says write out the first 5 terms of the sequence defined recursively by a sub 1 equals 25 and a sub k plus 1 equals a sub k minus 5. All right, so the next term I want to do is a sub 2. Well, k isn't 2. K plus 1 is 2. So what is k? 1. So this is saying a sub 2 equals a sub 1 minus 5. Well, we know a sub 1. So that's 20. If I want a sub 3, that's a sub 2 minus 5. That's 20 minus 5 is 15. So what's happening is the recursive formula is saying take the term in front and subtract 5. Take that previous term, subtract 5. So if I know that's the pattern, I don't need to keep working it out to get the first 5 terms. You just need to go until you get the hang of it. All right, everybody got it? So that's recursive. I went to an in-service. It is creepy. Yesterday I went to this in-service, so we were learning how to do things on the Promethean board, and I found this, and I was like, well, if you were asleep, you'd be awake. Except John. Okay. So, we have the definition of a factorial in Spanish. If you guys want to leave, she said, to try to let you out early, you'll need to watch the end of this, okay? So if you want to pack up and go. N factorial. Do you remember that N factorial? Like if I have 3 factorial, that means 3 times 2 times 1. The only other thing is 0 factorial is 1. So, my goal was to get to example 7 today. So if I have 8 factorial over 2 factorial times 6 factorial, I want to show you something that you can do here. And you're not using a calculator. 2 factorial is 2 times 1. But think about this. 8 factorial really means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, when I hit 6 and down, 6 down is the 6 factorial. So I want to stop there so that I can just cancel those. Then 2 goes into 8 4 times. 4 times 7 is 28. It's over 1, so it's just 28.
Oh my goodness.
This is a little bit abstract. Now, 2 factorial is 2 times 1. I look down in the denominator and I'd love to cancel the 5 factorial. Well, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Well, the 5 down is 5 factorial. So I can just cancel that, and then from here, you can look at it any which way you'd like. 3 times 2 is 6, so I just get a 2. Alright, now I'm going to go really abstract. And letter C, n factorial over n plus 1 factorial. Okay, that's really, really abstract. Think about this a minute. This means like 8 factorial over 9 factorial, right? If I have n factorial over n plus 1 factorial, that's like, and I can pick any number, 12 factorial over 13 factorial. That means in the bottom I have one more number than I do in the top. So watch what I'm going to do. This is going to go n factorial over, and think about this. This is starting at n and you just decrease by 1 until you get down to 1. So n plus 1 factorial means n plus 1 times n minus 1 times n minus 2 times n minus 3 all the way down until I get to 1. So now the n factorials cancel and I get 1 over n plus 1. Now letter D. Is there a parenthesis around the 2 with the n? No. So this means 2 times n factorial over n factorial, and the n factorials cancel. Letter E. Okay, which one's bigger, the numerator or the denominator? The numerator, just by 1. So watch what I'm going to do. I'm going to just start decreasing by 1. And then look, I get the denominator. There is a parenthesis around the 2n down there. And then those cancel, and I get 2n plus 1. In letter F, which one's bigger, the numerator or the denominator? Denominator. You guys are doing great at this. So I'm going to leave the numerator alone, and then I'm going to start with 2n plus 4, and then I'm going to subtract 1. And then I'm going to subtract 1. Well, then it matches with my numerator. Do you see that? This is like really neat. So I get 1 over 2n plus 4. Do not multiply it out. That's not the point. The point is just to simplify. Yeah. All right, example 7. If I want to find the first 5 terms, a sub 1 is 2 to the 1 over 1 factorial. That's 2 over 1 or 2.
A quick question.
Yes.
This is more than one day?
This is a 2-day lesson.
And is it book work?
Bookwork and a worksheet.
Okay.
There's a worksheet I gave you.
Like homework.
What?
What? I did not hear that. That's 4 over 2, so that's 2. A sub 3 would be 2 cubed over 3 factorial. That's 8 over 3 times 2 times 1. So that's 4/3. A sub 4, 2 to the 4th over 4 factorial. Now think about this. And you could reduce it first if you'd like. But here's how I think of it is 3 times 2 times 1 is 6. We already did that, right? And so you're just taking the 6 times the 4. Then 8 goes into both of those, 2 and then 3 times. So that's 2 to the 5th over 5 factorial. Then you're just going to take 5 times 24, and I believe that's 120. How did I reduce that? I got 4 over 15. Now remember, when you're done, because do you see what a big mess this is as you're working it out? Then somewhere list them in order. And do pay attention to how many terms you're being asked to do.